In our last trig section here, we'll be learning about two new rules, sine and cosine rule, to work with triangles that do not have right angles. Firstly, we have sine rule. So for any triangle, right angled or not, the ratio between a side and the sine of the opposite angle are equivalent for all three pairs of sides and angles. So for instance, here we have the length of side A is over the sine of the angle at A is equal to the length of side B over the sine of angle B, and so forth. Next, we have cosine rule. So for any triangle, the length of one side, C, squared is equal to the sum of the squares of the other two sides, offset by minus 2AB cosine C. So C is the angle opposite of length C. Okay. So one way to remember this is its similarity to the Pythagoras theorem, right? C squared is equal to A squared plus B squared. And since cosine 90 is actually 0, for a right triangle, we won't need this part, right? But for any other type of triangle, we will need it. So let's go ahead and try using these rules to solve the following triangles. So here we have a triangle at ACB. One, we need to find the angle CAB, so this one over here. And two, we need to find the length of AB, so this one over here. So let's just work that out one by one. So let's start off with A. Okay. So firstly, I'm trying to find A. And what I can see from what I already know, I know this angle and its opposite, and I know the opposite angle to A. So I'm going to use sine rule. So I'm going to go ahead, the sine of angle A over the opposite length is equal to the sine of angle B, which is 63. And I'm going to divide that by the length, which is 14. Okay, so now let's go ahead and rearrange. So sine A is equal to 10 times the sine of 63 all over 14. And so if I then go ahead and calculate that on my computer or calculator, I get that the angle is 39.53 degrees. Okay, and so I'll go ahead and note that down here since that might be useful for the next part of the question, B. Okay, so now I'm trying to find the length of AB. So again, perhaps I can use sine rule, but I don't know this angle yet. But luckily, I also know that all the angles in a triangle must add up to 180. So it's easy to calculate what the angle of C is, right? All I have to do is take 180 and minus the other two sides, okay, which gives me 77.47. Okay, now that I have that, I can use sine rule again. And so the length of AB over the sine of the opposite angle, which is 77.47, is equal to another length. So I'm just going to use 14 here, and the opposite angle, which is 63. And so to calculate this, I would do 14 times by sine of 77.47 over sine of 63, which, if I pop into my calculator, I will get the value 15.34. And there you go, we found both the angle CAB and the length AB. Next question. solve the triangle ABC in which AC is equal to 105 centimeters, AB is equal to 76 centimeters, and A is equal to 29 degrees. So, again, one of the easiest ways to start us off is to actually draw it, since without drawing it, it can be hard to picture what we're trying to do. So I'm just going to go ahead and sketch my triangle over here. I have A, B, and C. Okay. And so AC is given as 105. And then AB is given as 76. And the angle in between is 29. Okay. And so now solve the triangle means we now need to find all the missing values. So we have to find one length and two angles. So here I don't have enough opposites to help me out since the angle and the opposite side are not given to me. So I'm going to need to use cosine rule this time. So let's go ahead and use cosine rule to find the missing side. So from cosine rule, we know that the side squared is equal to the other two sides squared minus 2 times the length of the sides times by cosine of the angle in between, which is 29. Okay. So over here, if I plug that in my calculator, I will get 2842.069. And so I'm then going to go ahead and square root that number to get 53.31 as my missing length over here, which then means I need to find the missing angles. So let's go ahead and I'm going to jump back into sine rule now to go ahead and help me find these missing angles. So firstly, sine of angle B over the opposite length, which is 105, would be equal to sine of 29 over 53.31. Okay. And so if I were then to find inverse B, I am getting 72.72. Okay. And then let's go ahead and calculate the other side. So I do sine C is equal over 76 is equal to sine 29 over 53.31. And then, so if I would then calculate angle C, I am getting 43.72. Now, it may seem that we've now solved it, but if you're looking carefully, you might see there's something off. You'll see that if you added these three angles, 29, 72.72, and 43.72, you actually do not get 180. So we see that there is something wrong. In this case, it's likely that one of these angles is actually the obtuse angle, and we're going to need to find the other place where sine are equal to these values. Okay? And so if we remember the graph of sine, maybe I'll just draw that over here. There's going to be two places, an acute and obtuse angles that are equal to the same value. So what happens here is one of these angles we should be grabbing the obtuse angles instead of the acute. So let's go ahead and calculate it. So to find the corresponding angle, I just need to do 180 minus the other value. So for B, if I do 180 minus 72.72, I see that the value might also be 107.28. While for C, 180 minus 43.72 is 136.28. Okay. So now, looking at these values, I can go ahead and see which one is the correct value. I know 136 can't work. Why? Because then then the rest of the calculations will be over 180. So that means C has to be 43.72, and that means B must be 107.28 instead of 72.72. And there we have been able to solve the triangle since we found the missing side and the two missing angles. So, given any triangle, how can we know what to do to solve it? Well, firstly, we have to check if it has a right angle or not. Okay, so let's say there is a right angle. Then I'm going to have to check if you're trying to find an angle or angles are involved in your calculation. If there are angles involved in your calculations, then we're going to use our basic trig ratio, sine, cosine, tangent, to find the missing piece. If there aren't any angles involved, all you have to do is use Pythagoras' theorem. Meanwhile, if there are no right angles in your triangle, you can check if you know a side and its corresponding opposite angle. Okay? So if you know a side and its opposite angle, you are going to use the sine rule to calculate the rest. Do note that if you are given two angles, you may need to calculate the last angle and still use sine rule. Otherwise, you can go ahead and use cosine rule to find whatever is missing. And that wraps up our trig sections.